Assalamu alaikum friends, my name is Bilal Khan and this is my 18th video of DevOps. So in this video I am going to talk about Docker. Alright, but before discussing what is Docker, let's discuss that applications are running on the servers. Alright, we know that applications are running on the server, but there was a time in which only one application was running on one server. Alright, this is a previous time in which only one application was allowed to run on a single server. Alright, so let's take an example that here is a server, alright, and inside this server only one application is running. Similarly, there is another server and inside this server only one application is running. Alright, so how to run multiple applications or instances of an application running on the single server. So to solve this problem, virtual machines came into picture. Alright, basically the virtual machines solved this problem, and there are a lot of softwares like VMware and other softwares that are the virtual machine, and that is basically solving this problem. Alright, now let's answer a question that what is a virtual machine. So virtual machine will allow multiple applications to run on a single server. Alright, so even if it is better than one application running on one server, as we have seen in the previous slide, but it is still not perfect. Why? Because the virtual machine requires its own operating system. It means that if you installed a virtual machine, similarly if you have 2 or 3 or 4 virtual machines inside one server, so there will be 4 extra operating systems. Alright? So the operating system uses a dedicated amount of CPU, RAM and hard disk, etc. Alright? So this is a thing that you need to keep in mind, that every operating system requires some kind of resources. It requires time to boot to another operating system. Alright? So if you want to switch from one operating system to another operating system, it will take time to boot to another operating system. Alright? It is not fast. Why? Because now the operating systems are a lot, but the resources that are present inside the machine have some limitations. Alright? In this way, the resources will be distributed among different operating systems, because in one machine we are running multiple operating systems, so the resources of this one machine will be distributed among multiple operating systems. Alright? For this reason, the machine will not work fast. Alright? Instead of it will work slow. So there may come issues with licenses in operating system also. What is this licensing? So as you know that Linux is free for home usage and commercial usage. But when it comes to Windows, the Windows operating system allow us to use it in home for free. But when it comes to commercial usage, the window is not free. Alright? So in this case, we will have to pay the license fee for the Windows operating system for the commercial purpose. Alright? So if there are multiple operating systems virtually running on in a virtual machine, so you will have to pay the license fee also. You can also use the pirated version also, but this will be an illegal task. Alright, this will be an illegal option. So if you want to go to in the legal way, you will have to pay for the license fee also. So it overloads the machine. Why it overloads the machine? Because there are multiple operating systems running on a single machine. So there will be a load on a single machine and they will not load the program properly. So this will be the overload. Alright? So teams communicate and exchange data between each other. We know that teams communicate and exchange the data between each other. But previously the developers were creating an application in virtual machines. Alright? So you need to remember that previously the developers were creating an application in virtual machines, and after that they were creating the whole image of virtual machine and transferring it to the next team. Alright? So let's say there is a team of software developers, and this team is assigned a task to make a software. Alright, they made a software, and now the next step is to they made a software in the virtual machine. Alright, in the virtual machine. But now the next step is to convert this operating system, this virtual machine, into an image, alright, into a copy. Now they will create an image of the whole of virtual machine, of the whole operating system, alright, and after that they will transfer this whole image of the virtual operating system to the testing team. Alright, now the testing team will test the whole application that the developers have created. Alright, so in this way the testing team will also use the virtual machine. Why? Because to run the images, to run the image of an operating system, they require a virtual machine. Alright, so in this way the developer side, on the developer side the virtual machine is present, and on the testing side the virtual machine is present. Alright, so in this case, because the image contains all the necessary files to be used in an application, and the receiving team was also using VMs to use that image. Alright, so because the image is transferred, it contains all the necessary files. That's why the image is transferred. But here the question arises, and the question is that instead of installing multiple operating systems, why don't you just take the files that are required for an application to run it? Alright, the main purpose of using the virtual machine is that we are requiring some files to be used in an application. So why don't we use the operating system for this? Alright, because the reason for this is that virtual machine does not provide the functionality to only send the applications or to only send the files. Instead, it will send the operating system with files. Alright, so it will not allow us to skip the operating system part. It will allow us to make the operating system, and then inside the operating system we can create some files. Alright, so this is not the functionality that the virtual machine provides. Now what is the solution? The solution is the containers. Alright, so the container contains all the necessary elements to be used in an application. Alright, so there is no need to install the operating system. Instead, you can put the data, you can put the files that are required for an application, and that container will be transferred to the another team. Alright, and the team will run this container. So in this way, there is no need to create an image of operating system to be transferred. Alright, you can just create a container, and a container will contain all the files that are required for an application. Alright, so let's take an example that here is a container. Alright, the container is not in physical shape. We have seen in the physical world, in the real world, but it is a software. But I have given you just to show you an example. Alright, so here is a container, and these are some of the files that are required to run in an application. Alright, so what you will do, you will put all these files inside the container, and once these files is inserted inside the container, you can put those, you can take this container and take it to and transfer it to another team or any other place. Alright, in this way the container will be used there, and it will use all the files that are required. Alright, so an application will work in an isolated environment in a container. Alright, so the container will not know that what is happening outside the container. Instead, it has some limitation that it will not be aware of the things that are happening outside the container. Alright, so that's why the container has some kind of limitation, that it will work in an isolated environment. Now here is the difference between containerization versus virtualization. So here you can see in the virtual machines there is an infrastructure, means this is a machine that has some resources in it like RAM, CPU, hard disk. Alright, and after this infrastructure, here is a hypervisor. So what is a hypervisor? Let's move to the next slide. So the hypervisor is used to create multiple machines. Alright, it will create multiple machines on a host operating system, and it manages virtual machines. So it will divide and allocate the resources on various pieces of hardware. So the first work is to create multiple machine, and the next is to allocate the resources. Now let's move back, and as you can see that here are three operating systems. Alright, so the hypervisor is creating these virtual machines, these operating systems. Alright, and to allocate the resources, to give the resources from the infrastructure, the hypervisor will be used. So let's say this operating system is requiring some resources, so the hypervisor will take these resources from the infrastructure and it will allocate these to this first operating system. Similarly, the second operating system is also requiring some kind of resources, so they will the hypervisor will give those resources to the second operating system. Similarly, this situation is also happening with the third operating system. Alright, and after that, the application one will, with all the binary files, with all the files that are required, will be present in the first operating system, and the second application will be present in the second operating system, and the third application with its binary files, its required files, will be present inside the third operating system. Alright, this is the functionality of the virtual machine. Now let's move to the container. So the container contains the infrastructure same as it is. Alright, and now instead of having an hypervisor, because the hypervisor will create multiple virtual machines, multiple operating systems, and allocate the resources. So in containers, we don't need to have multiple operating systems. So that's why we will not use this hypervisor. Instead, there will be a main one operating system only. Alright? And in this operating system, there will be a container engine. Alright? This container engine will contain multiple applications. Alright, like application 1 with all its binary required data, application 2, application 3. Alright, so there is no need to install multiple operating system if you can use multiple applications in one container engine. Alright, so the containers can be used in Windows, Mac OS, and Linux. Alright, if a Windows-based application is containerized, means if the application is deployed inside the Windows operating system, then it will only run in Windows operating system. Alright. Similarly, if the application is deployed inside the Linux operating system, it will only run in the Linux operating system. So by using container, there is no need to install multiple operating systems. Alright, we have discussed in the previous slide. So the containers run in these applications. Alright, what are these applications? So for Windows, this application is the Docker desktop. You can run the container inside the Docker desktop. You can also run the container inside the WSL, means Windows subsystem for Linux. Alright, and in Mac OS, you can use in the container in the virtual machine. It means you can install the virtual machine inside the Mac OS, and in the virtual machine you can use the container. This is also possible. And you can also use the container inside the Docker desktop. Alright, so the Docker desktop is providing the functionality for the Windows, Mac OS, and now I have visited a website. It also provides the functionality for the Linux also. Alright, but for Linux, as it is, because the main container is created in the Linux operating system, so there is no need to use the applications to run the container. You can run the container as it is. Alright. So here is another question, what is Docker? But before discussing what is Docker, let's close this slideshow and move to another tab. Now you can see that I'm currently in the website docs.docker.com. Alright, in this website there are multiple tools like Docker Desktop, Docker Engine, Docker Compose, Docker Hub, etc. Alright, so let's move to the Docker Desktop. As you can see in the Docker Desktop, I have the Mac OS installation process, Windows, and Linux also. Alright, so if I want to install the Docker Desktop inside the Mac OS, I can click on this, and let's take the installation process. Let's take a look at this. As you can see that it is asking me for the system requirements, for all the details that are necessary for to install the Docker desktop. You can also uninstall it. Alright. Similarly, if you want to use the Docker desktop inside Linux, you can take a look at this. Alright. These are some of the commands, these are the requirements, these are the platforms like Ubuntu, Debian, Fedora. Alright. So after that, let's close it and move to the Docker engine. Let's install, click on the install button, and now the Docker engine is present for these platforms like Linux, Mac OS or Windows, and these are the servers like CentOS, Debian, Fedora, etc. I am using Ubuntu, so I will click on this, and these are the requirements, these are the commands for uninstalling the old version and installing the new one. Alright, so these are the setup, how you can set up the repository and install the Docker engine. So you can take a look at this website. It will contain all the information that are required for installing Docker desktop, Docker engine, Docker Compose, and all the tools in the Docker. Alright. So let's move back to the slideshow. After that, the next question is, what is Docker? So Docker is a company and Docker engine is a tool. Alright. So many people misunderstood it that Docker engine is a Docker. No, Docker engine is not a Docker. Instead, the Docker is a company and Docker engine is a tool that helps us in creating, managing and scaling the containers. So if you want to create, manage and scale the containers, Docker engine will be used. So a developer defines all the applications and its dependencies in a Docker file. Alright, so the Docker file will contain some kind of commands. Inside these commands you can access the file. Alright, so in the Docker file you will contain all the files, all the commands that are required for an application to run. Alright, so after this Docker file, the image will be created from this Docker file. Alright, and that image defines the Docker container. Alright, so a Docker file is a recipe for creating Docker images. Alright, so you can create Docker images with the help of Docker file. A Docker image gets built by running the Docker commands. So inside the Docker file there will be some commands that you can use to create the Docker image. A Docker file is a source code, the image is an executable, and the container is a process. So with the help of container, with the help of this process, you can run the application. So you can run 1000+ containers from the same image. Means from one image, you can use multiple containers. That's why container is a running instance of the Docker image. Alright. So let's take a look at this example that here is a Docker file. It contains a list of instructions, and with the help of this Docker file, you can create the Docker image. And after creating the Docker image, the container will be created. Alright. So you don't need to share the whole running application. What does it mean? That let's say your friend likes the food, likes the dish of your home. Alright, like the food or the dish from your in your home that you create, that you have made it. Alright. Now your friend wants to have this same dish in his home. Alright, so let's say your friend is located in another city. Now how you can transfer the food if he is present in another city? So if you send that food, if you send that cooked food to your friend, when the food will arrive there, when the dish will arrive there, it will be in a bad condition. Alright, so how you can transfer the food? So instead what you can do is to send the instructions, send all the recipe, and when your friend will receive this recipe, and if he follow the same instructions, he can enjoy the food. That is, he can enjoy the food as it was present in your own home. Alright. So in this way, you don't need to run the whole running application. Instead, you just need to share the instructions of an application, and by following the instructions, the receiver can get the required results. This is the simple point of it. So Docker has three parts. So the first part is the Docker runtime. Alright. Inside this Docker, the first part is the Docker runtime. After that, there is a Docker engine. After that, the third part is the Docker orchestration. Alright. So the first part is the Docker runtime. So basically it will allow us to start and stop the containers. Alright. And it is of two types. The first type is the low level runtime or run C. It works with operating system and starts and stops the container. Simple as that. The second part is the container D. So it is also a project of CNCF. So it manages the run C, alright. The container D manages the run C and it connects with the network. And it pulls the images from the internet. What are the images? These are the Docker images. So it will pull the Docker images from the internet. So now let's move to the second type of the Docker. The second type is the Docker engine. So Docker engine is used to interact with daemon or server. So what is daemon? So daemon will basically listens to the API request and processes them. So let's take an example. That here is a server or a daemon. After this server, here is a REST API that will build the communication between the server and the client. Alright. So after this REST API, there is a Docker CLI. Means it is a command line tool that you will give the command in it and it will perform the functionality according to the commands. Alright. So this is the client part and this is the server part. So you will give the commands inside the Docker CLI and after this the command will be transferred to the REST API. Alright, it will build the communication between the client and the server and now the server has received this command and after receiving it, it will give this command to the runtime. The runtime will perform functionality according to the command. Alright. So the next part is the orchestration. So what does it mean? So let's say that your application is running in 10 containers. Alright. And you want to scale them up to 20 containers. So in this way you are increasing the size of containers. So let's say here is another example that few containers got down and you want to restart them again. Alright. And the third example is this, that let's say multiple containers contain the version 1 of an application and you want to update them with version 2. How you can do this? With 1 or 2 containers you can do this manually. Alright. So these things require time to do it manually. So with 1 or 2 containers you can do it manually, but let's say if there are hundreds or thousands of containers, you can't do this manually. Instead, it would be cool if you automate them all. Alright. So to solve this problem, the orchestration comes into picture. So basically the orchestration will automate all the process and it will manage the containers that will be created or deleted. Alright. That will basically manage the containers. So there are some tools built for orchestration like Docker Swarm or Kubernetes. Alright. So Kubernetes is also a CNCF project. So it not only performs the automation, but there are more things that the Kubernetes perform. Alright. So let's take a look that you can learn about Open Container Initiative by clicking here. Here is a link, but I can open this because I have opened this previously. So you can take a look at this article, and basically this article is the Docker and the OCI runtime, means the Open Container runtimes. So there are multiple runtimes. So let's say that the OCI currently contains 2 specifications, the runtime specification and the image specification. Alright. So there are multiple runtimes like Container D, LXC, RunC, CryO, RTK. Alright. So every runtime performs some kind of functionality. Alright. So if you want to know more about these runtimes, you can check this article from start to the end. It contains very valuable information. You can read them all. Alright. So after that, let's move to the slideshow again. And what we have learned today. So what is a virtual machine and a container? Number 1. What is a hypervisor? What is a Docker? And what is the runtime, Docker engine, and orchestration? Alright, these are the things that we have discussed today. So that's it. I hope you like this video. So if you liked this, then make sure to subscribe to my channel. And if you have any questions in your mind, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.